Yes, good morning, everyone. The presentation has several authors, as you can see, because obviously our team is much bigger. The guidelines for interchange design, this is just one of the elements of the new road design standards, and I said that yesterday. And I'll be really quick with identifying the previous problems. Why do we want to not really change, but why do we want to write those guidelines in the first place? And I've picked some elements regarding design requirements to talk you through in more detail. So identifying the problems. Well, we really haven't had specific guidelines. Everything was based on knowledge from the 1990s. There were some design parameters, but we used the term of non-urban interchanges. There were no parameters for urban interchanges under difficult conditions. And when it comes to design speed on the ramps, the approach was really very rigid. Selecting the type of interchange, well, there were some limitations on this. I mean, I don't see why we would stop or people from designing interchanges on specific types of roads. And obviously, some boundary conditions have to be met, because what we don't want is a WB interchange at a crossing of an expressway and a motorway. But we thought that needed to be made more flexible in terms of selecting interchanges. And then passability, again, just as with junctions, our idea is to include passability, including conditional passability. Just to give you an idea, if it's a single lane ramp, 6 meters wide, why would we make it wider if it's not needed? Sometimes it may be needed, sometimes not. So that shouldn't be a requirement. And then weaving sections, it wasn't clear what dimensions they should have. And then on-ramps and off-ramps, I think what we've had especially under urban conditions, wasn't sufficient. And lighting, that's another problem. So lots of problems, and it's based on our analyses and results of our audits, because we've conducted 32 projects, as I said, and that helped us to identify the problems and the deficiencies. So now we have this structure. There are 3 volumes with basic requirements in volume 1, where we list all the typical things like classification, elements, design data, etc. And then we have interchange elements and technical equipment. I'd like to tell you more about the basic requirements. This is really a very important volume, because we want to give designers more flexibility and more freedom. And this is why volume 1 is going to be really important for them, because it lists functional and technical requirements, which they will be able to translate into practice based on volume 2 or based on their own knowledge, as long as they meet the basic requirements. So those have to be met regardless. And volume 3 describes the technical devices or the equipment. I've picked some elements to talk you through when it comes to the design requirements and the guidelines. Yesterday, Dr. Budzyński showed that before, so I have a different example. The complex interchange. This is one of the main problems, and whether any deviations are allowed here for short distances. So when it's a complex interchange, it's not just about the short distance, but what makes it complex is that it has common elements for 2 neighboring interchanges. So obviously, we say that it's okay to do this, but we have to be clear about the specific conditions. But there's a new element there, which is what's called neighboring roadway or carriageway. So it's just as you can see here, this looks like more of a local road, but it moves into an interchange. So that's a departure from the orthodox approach, where you're not allowed to do interchanges this. But now that we use the neighboring carriageway idea, then it's okay to do this, where we can have entries and exits going straight into a local road. It says SGP in the parentheses, and obviously there are specific requirements regarding speed, etc. So this is just one of the examples of what's new. There's another term which is defined in detail, where the quality of traffic on junctions has to be assessed. What we think as the authors is really important about this is that on the one hand, designers are allowed more freedom and flexibility, but they are also required to prove, to demonstrate that whatever they come up with will be efficient. And this means we have to have specific capacity for entries and exits and weaving sections. While we don't want to be overly rigid with our requirements, we allow them some freedom. But the question is, are we going to reach the free flow parameters that we want to get? The other thing is access to calculation methods. Some of them have already been developed under the RID program, but there are also other methods that we can tap into. But the main thing is it's a credible traffic forecast. That's a precondition here. So you have to be clear about the traffic. And number two, it's not just about applying the typical entry. Instead, you have to be able to demonstrate this, that your solution will ensure proper operation of the junction. Next up, well, it's modification. I would say modification because the changes aren't that significant, but we are now using the new term that's speed to be designed, and this is for ramps. And again, we now have a new set of speeds, but it's also made clear is that it could be up to 100 kilometers depending on the function of that link within the interchange. Because what we don't want to do is to reduce the speed artificially. Let's say if this is a direct ramp and it's so well positioned that it can accommodate a higher speed, could be 80 kilometers, and then it's okay to apply parameters for higher speeds, because the idea is to make it an efficient link. And again, when we have difficult conditions, and that was defined today already, it's okay to reduce the speed on ramps, but there is one condition. This has to be tied in with the speed on the main carriageway. So that's another requirement. That way we will ensure that traffic there will be smooth. And other requirements regarding interchanges is the dimensioning of exits and entries. This is deacceleration section, so that's exit. And here's a formula, which is pretty simple, but we have charts where we can better assess the speeds, whether it's the carriage way or the ramp for deacceleration. So you can then maneuver with the time lost, but you can always look up the range and the guidelines, because you don't want is a delay of 5 to 6 to 10 meters per square second, because this should only be applied to unusual situations. But this could be down to 2.5 meters or even less, which gives the designer some discretion. So we know what the normal parameters should be, but you have some freedom to modify that. I mentioned that having a set of typical entries and exits, that's just not enough, especially when we operate under difficult conditions. So entries can also be designed for the left-hand side as opposed to the right-hand side only. So that's obviously defined in the new guidelines, and it may be okay as well to design for the entry from the left-hand side. Well, obviously, this is just one example, and there are many more, but there's one other thing, which is quite a change compared to the previous guidelines. That's sight distance. On approach, no change there, but there is a new sight distance requirement, which is along the entire merging lane. This is something that comes up when we do audits, when we do classes. So when you have interchanges on curves and limited visibility, because you lose sight of where that lane is going. So this is a new requirement. We've defined the parameters for that, and that should help to increase the safety of interchanges. What we've also done, and this is also based on German models. This is a recommendation for the typical interweaving sections. This is just a piece of what we have. So typical interweaving sections and the conditions. So it's not like it has to be 180 to 250 meters. Instead, we make it clear when it can be 150 or 250 and what interweaving model this should be. Now, with this, we should be able to eliminate mistakes that are made when the weaving sections are too short, because that makes the interchanges more hazardous. When it comes to WB interchanges, the ramps were not properly designed, and one thing was ignored, because this is the aggregation zone. So when there's signalization, obviously a queue will build up. But we have this requirement for the deacceleration section to be dimensioned from the moment the exit begins. So we slow down from the initial design up until the end. And so we assume that the reduction is from the main carriageway to the ramp speed. And then we have to continue reducing the speed up until the section where queues build up. So that's now been made very clear, because by doing this, we can improve road safety. And there are also some limitations on what delays are allowed. I only have a minute left. I'm measuring the time for myself. And I couldn't possibly talk you through all the elements. And just as I said yesterday, this is what the Ministry of Infrastructure wants. We will have a round of consultations. We are going to have webinars, and obviously, when we do that, we will discuss the details of the new proposals. So the fact that I'm not giving you too much detail, whether it's myself or my colleagues, but obviously when we do the consultation, we will give you the details. So the idea for the new guidelines is to offer standard solutions and allow non-standard ones. It's okay to use a catalog of standard solutions, but it's also okay to use your own discretion. The main idea is to improve safety, and as I said, we've eliminated some of the rigid solutions where whatever you design has to go through a checklist of functional requirements. And we've added some new content, but there's a really very important thing in the new guidelines, because there are requirements for pedestrian and cycling traffic, because interchanges are also used in cities, and we haven't had any sections for pedestrians or cyclists there. And also the equipment, additional equipment, and that's described at length, but it's things such as traffic control using ITS. Well, thank you very much.